Hi guys, it is Mr. Ansomir here live from my basement. I'm recording this lesson today. Unfortunately, my uncle passed away and I'm going to be out on Thursday, so in lieu of me being there live, I'm recording this for you. The purpose of today is we're going to be learning about random numbers in Java. There's two primary ways to do that. I'm going to walk you through both. So we'll start here in Dr. Java. We'll put our header at the top, random numbers in Java, public class. Don't call it random because, as you're going to see here in a moment, that is one of the classes that you're going to be using. So don't just call it random. I can do it something like random notes. That is something that's easy to overlook. You don't want to call your classes like math because it's built in. You don't want to call it graphics. That's also a built-in class, and that'll override any of the classes that you already have. So, in our main function, this is method number one. This is the tried and true that we've done many times over the years. We are going to first print out the value of the math.random method. The random method comes from the math class. If I compile this and then I run this, I get a decimal. And this might shock you. If I run it again, I'm going to get a different decimal. If I run it again, I'm going to get a different decimal. Oh my gosh, it's pseudo-random. So, the math.random method will generate a pseudo-random number from 0 up to 1, but again, not including 1. It is inclusive on the left, exclusive on the right. I have told you that many times over the years. So for those of you that are old enough at this point, it is written in this style with the interrow notation. You have 0 inclusive, 1 exclusive. And I shouldn't really say pseudo-random number, I should say pseudo-random decimal. So from there, of course, we can multiply by the range. The range, if you recall, is the highest number minus the lowest number plus 1. So we'll start with something easy. If I want a number from 1 to 6, let's say a random dice roll, I can multiply by 6. Quite simple. And when you do that, that will, of course, give you a larger decimal, 4.65 in this case. Still not an integer. We'll get to that in a second. We're going to add the lowest number in our range. So if I want a dice roll 1 to 6, I will come on here and I will say plus 1. The order of operations says I'm going to multiply before I add. So if I were to multiply that, can't really tell obviously, but now we're going to be getting still a decimal. So the final part of this is now to typecast into an integer. You got to be careful about how you do this because there is an order of operations. If I put int there, and my highlighting's all messed up, if I do this, you're going to be extremely disappointed with the result because I get 1. That seems okay. I get 1. I get 1. Here's what's happening. It's taking the math.random and it's typecasting the decimal into an integer. A decimal from 0 to 1, it's typecasted into an integer, is going to give you 0. 0 times anything is 0, and it's going to add 1. This is not the way you want to write it. You want to make sure that you typecast with the entire random number formula in a quantity. If you neglect to do that, you're going to always get just the lowest number because everything else will just go to 0. So now I will get different random numbers. Just so that I can prove this to you, if I do a quick little for loop from 1 up to 10, let's say, just give me 10 random numbers. Wait for it. There we go. Random numbers. So, this formula, we've done this now in Python. We've done it in Visual Basic. We did it sort of in C++, although it was a tiny bit different. Using the percent sign because this won't give you an integer, but again, this goes back to what we've done many times over the years with this formula. So just as a reminder, the range, because people still struggle with this, the range is not the highest number. It will be in the case where it starts at 1, because if you go 1 to 6, you're going 6 minus 1 plus 1. It'll work out to be the highest number because the 1s will cancel out. So let's say we want to have a random number from 100 to 200, let's say. Well, in that case, we have int, we have math.random. The range, highest is 200, lowest is 100. 200 minus 100 is 100, plus 1 is 101, and then plus 1, hundreds. That would be the proper formula for 100 to 200. If I want a random letter from A to Z, capital A to Z, remember in ASCII 65, 26 more letters would be 90 because you conclude 65. System out print ln int math.random. How many letters in the alphabet? 26. Add 65. That would give you a number from 65 to 90. I get letter Z, but of course we can't see the character until we convert it, so if I put the typecast in front of that, letter C, letter N, let me put a little loop around this, just for funsies, go from 1 up to 10, x plus plus, take that, make it a print instead of a print ln, so we're going to get 10 random letters side by side. There we go. So that is one method for making random numbers in Java. Method number 2. This uses the random class from java.util. Now, before we start, which one of these is better? Neither. I mean, they're both going to do exactly what you want them to do. I've always preferred the first method because it's almost like a universal method in computer science. Not every language has a built-in random function. So whichever one you use is perfectly fine with me. I want you to be familiar with both because it comes up as both on the exam. And it's actually pretty straightforward to use. We're going to go up top first. We're going to say import java.util.star. Then, just like we use the scanner class, we have to instantiate an instance of the scanner class. We have to do that for randoms as well. So we're going to say random, and then let's pick an object name. How about R equals new random. So by doing that, R, just like scanner input, we say input dot. Well, R is now going to be our object where we call the methods from. So what we do first, again, be sure to import java.util.star at the top. Let me give myself a little space here so you can see this a little bit better. From there, we create an instance of the random class at the top of your program. So you can check that out. Now, we want to call upon a method from R. So it's not random dot, like it was math.random. Random comes from math class. In this case, the random class, the methods come from R, not random. So we don't say random dot, we say R dot. So let me do that. System.out.println R dot. And what what methods are it? Well, there's a couple. Let's do next int. And here, let me put a little break in so we can tell where something starts and something ends. So let me do this, something like, there we go. Let's try it out. So that's quite the number there, 175342644. Let's run it again. What in the heck is going on? Well, it's giving me a random integer, and it's not all that helpful in this state because it's going to give you a random integer up to the boundary of an integer, that whole 2 billion number. So what could we do to limit this? Well, let me do r.nextInt 6, let's say. By doing this, I'll get 1. Try it again. So there's negative. Remember that integers can be positive, negative, but besides the point. You know, we're probably not going to use this very often, but this, 6. Seems like it's limited to 6. Well, you know, again, let's do a quick little for loop. Let's do 20 of these. Again, just for funsies. And let's check out what we get. Something interesting happened here. I want to make sure you see this. You get zeros. And also notice what you didn't get. You didn't get 6. You got 1, you got 2, you got 3, you got 4, you got 5, you got 0. You didn't get 6. So the next int, when you put in a number, next int with the number generates a random integer from 0 up to the number minus 1. It's much like an array, the length of an array. If you say the array is length 6, it goes 0 to 5. It starts on 0. So if I want to take those numbers and shift them to give me 1 to 6, I still have to do this. I still have to say next int 6 plus 1. And now I will get some nice little dice rolls. Okay. So, you know, once again, which way is better? I mean, ultimately, they really kind of do the same thing. One thing that you can do with the random, you can generate randoms of different types. I could say, give me 1 up to 20, and let's generate r.nextDouble. And you know what this gives me? Look at that. It gives me a whole bunch of decimals. It gives me a bunch of doubles. And you know, guess what? You know, is that significantly different than what math.random would do? Because math.random gives you a decimal, and it sure seems like these are decimals from 0 to 1. So, you know, however you cut this, it really is the same process. If you wanted to, you could do a next float. Woohoo! Very exciting. So in this case, now you have floating integers. You have smaller numbers because doubles hold more decimal places than floats do. But you get the point. So whichever one of these you want to use, feel free. Ultimately, it doesn't matter. So at this point, we still have some time remaining in class. I'm not going to record a half-an-hour video for you to watch on random numbers. But what you can do is you can start getting started on the online GDB programs that I have for you. There's a couple that are going to be due this week. Next week we're going to be doing recursion, and we will have a couple more programs next week. So check those out. If you have any questions, let me know. Hope you guys are well, and we'll see you when I see you. Take care.